Good morning everyone students. So this is Shivakumar from St. Joseph College of Engineering in the EEE department. So already we discussed about the control system and the basics in the control system, what is meant by the basic components which is present in the control system. We already discussed it. So now what is we are going to discuss is the translation system and the mechanical system, force voltage analogy and force current analogy, and those things we are discussed in the previous videos. So now we are moving to the next topic in a control system, which is a block diagram reduction. Okay, so before we are reducing the block diagram, first we know that what is meant by block diagram. So in a control system, so now we are going to discuss about block diagram. So first, what is meant by block diagram? So we know that every physical system can be represented with help of a mathematical equation. Okay, so we know that every practical and identical systems are represented with help of physical equations, with help of any equations. So those equations can be represented with help of a block. Okay, so any equation we can represent it. For example, if you are having a equation, a sensor or any element with some input, so I am representing that particular element or transducer or sensor or even any physical process with help of a block diagram. In that it is having some input and it is having some output. Okay, this is a output and this is a input of the block. Okay, what does this block represent? It is a system element. So the system element can be of anything. It may be a process, or it may be a final control element, or it may be any summing element, or it may be a feedback, or it may be a processes, anything. Okay, generally in the control system we are representing a element in the control diagram is a block. Okay, so we are having the n number of blocks in the control system of any particular equipment or any particular system. Okay, so these blocks is nothing but a physical equation. The block represents the physical equations, and which will get some input and it will process the input, then it will give some output. Okay, so it may be the block can be having some gain. Okay, it will process, so it will having some gain, so the block gain will be represented by G in general. Okay, so the input is processed with the block and it will be forwarded to the output. Okay, this is a general block means. So we are having a number of blocks in a control system, so that's why we are calling it as a block diagram representation of the control system. So this block diagram representation is represented with help of the transfer function. So here the block, I said you that what it is present here is transfer function. So because we are not representing any physical equations directly in a time domain, we are representing in a S domain. So in a control system we know that every system is represented with help of the S domain, that is in a transfer function. So the transfer function of input, transfer function of output will, if you get the ratio of those things, we will get the transfer function. Okay, the Laplace of output by Laplace of input is called as the transfer function. Okay, so this block diagram, in a block diagram technique we are having three important things. The first one is a block. What is meant by a block? Okay, and so we know that first one is a block. What is a block? We discussed it. And the second one is the summing point. Okay, what is meant by summing point? So we know that in a control system it may be a feed forward or feedback, and feedback plus feed forward, anything. So the summing point, if more than one signal are coming into the system, then we are going to summing those signals. Okay, that is called as the summing point. For example, it is represented by a circle with a cross. The summing point can sum n number of signals into a one output. Okay, for example, we are having a signal A and signal B, and these two signals can be summed up and we will get a output. Okay, so it is signal A with a plus and signal B with a minus representation. What this means that the signal is added with the positive sign, and the second signal B is added with the negative sign. So the result of these two things is A minus B. Okay, what is our normal mathematical calculation? In the same way, we are adding the signals in the control system. In the block diagram, it is called as a summing point. So not only the two signals, it can sum n number of signals. So if you are having another, if you want to add it another signal with a plus or minus, we can add it that. If you want the plus, that is addition of another signal, it is a C, then we can add it as A plus B minus B plus C. So in such a way that we can add this summing point can be used for summing n number of signals in a control system. So that is represented, that is done by this summing point in a block diagram representation. And the third one, so the third one is branch point. Okay, so what is meant by branch point is, so when the signal is coming, so it can be branched out to the many paths, or for to many element the same signal can be given. For example, I am getting the signal A and it will be given to some block G1, and the same signal A can also be given to some other element which is present in the control system. Okay, that is also possible. So then what we are going to do is, so we have to write the branch point. So the name is branch point, and this is a branch point. So the A signal is given to the block G1, and the same signal will also be given to some other part of the block diagram or a system. Okay, so when the signal is tapped out, when the signal is tapped out to the many elements, then that point is called as a branch point. So these three things are very important while you constructing a system with help of the block diagram. Okay, we can represent the system in a mathematical or physical equations, and also we can represent the system with help of the transfer function, and we can also represent physical equations with help of our block diagrams. And we are also having the another concept which will be a simplified form of the block diagram, is called as a signal flow graph. Okay, we will in a forthcoming or the upcoming videos we can discuss about those things. So now we are going to discussing about the block diagram. So these three are basic points which is present in a block diagram construction of any control system. Okay, so in a constructing the a control system, so we need some rules and regulation. Okay, so what are the rules we have to follow while you are constructing a block diagram of a system? Okay, so what are the rules is, so I can erase it and we can discuss the one by one rules. Okay, so first rule number 1, so first one is the rule number 1. Okay, the rules for block diagram algebra. Okay, that is called as RU, rules for block diagram algebra. That is, algebra is nothing but we are reduction, or we can call it as block diagram reduction. Okay, so this is a rule. Okay, we have to follow it up. And first one is rule 1, combining of the block diagrams. Okay, so combination of the block diagram, So how you are combining the blocks is called as a rule number 1. So first one is combining blocks in a cascade. So what does a cascade means? So one after another. So we are having the two blocks one after another. So we are cascading those signals, okay, on blocks. So first one is, we know that we are taking A is a signal and it is given to the first block is with a gain G1, and again it will be given to the second block which is a G2, and the signal is given after that to the some other part of the your control system. So now you take that, what is the output of the block 1 is, it is A into G1, you will get A into G1. Then the A into G1 is again processed to the G2 block, and we will get the final output is A G1 G2. Okay, so the same thing can be attained by reducing this into a single block. When the two blocks are in a cascade, just you can multiply the both the blocks. So we can get A and the block A, it is G1 G2. So if you see that, again the same output you can get it from the this block. So while the blocks are in a cascade, just you can multiply the transfer function or multiply the gain of the blocks. Okay, that is the first one. And the next rule 2. So what is the rule 2 is, so we can see that when it is connected in series, we have to just multiply that one. When the blocks are in a parallel, what we have to do, just we are seeing that. So we are having the A is given, again you can take the same thing G1, and it will be given to some summing point, okay, with the addition plus, okay, you take the second one. So the second thing is the same signal is taken and which is provided to the some other gain function G2, and those G2 is again added back to the here the two things are in parallel, okay, the same signal given to the two blocks, and it will be again combined here. Okay, so if you take this also here added with the signal, then both the signals will be added up. So the first block is G1, second block is G2, and the same signal is given to things. So the two things are in a parallel, and here the two blocks are in a series. So what is the resultant of this one is, here you will get A into G1, and this is A into G2, and you will get A into G1 plus G2. Okay, so the resultant is, we will get when they are in parallel, AG1 plus AG2, you will get A into, commonly if you take A outside, A into G1 plus G2. So you can simplify this one as the A signal is given to the block. When they are in parallel, you have to just add up the gain. You will get the same A into G1 plus G2. Okay, so this is the second rule. While the blocks are in parallel, we have to add the gains. And the third one is, so moving the branch point of the point. So moving the branch point, okay. So when the blocks are in parallel, and this is a moving a branch point, okay, it is a moving a branch point. Okay, moving a branch point ahead of the block. Ahead of block. So what is this is, so you know that branch point, so we are moving ahead. So we already taken that if you are the signal A is given and it is given to the block G1, and I am tapping something, okay. So if instead of taking here, I am taking after the block, okay, ahead means after the block. So what will happen when we are moving after the block, so you will get, so I am taking A, so here the signal is A is getting out, okay, it is GAG1. Okay, here if you take A and it is given to the G1, and after the block, ahead of the block means after the block we are taking tapping. Okay, so if you take what you will get A into G1 AG1, so we have to multiply it with 1 by G1. If we multiply with 1 by G1, G1 into G1 will get cancelled, we will get A as an output. So you will get A, and this is whatever it may be, this is going. Okay, so in this way, when the tapping point is ahead of the block, just you have to multiply with the inverse of the gain in the block. Okay, in the same way, the rule 4 is moving the branch point before the block. Okay, so instead of this one, so if you are moving before the block, for example, moving branch point before the block. So in the before the block means, so we are having the A and it is given to G1 and we are getting an output, and from this if you take that AG and this is also AG, if you take it as a AG1 and if you tap it here, this is also AG1, correct? And I am going to move this branch point here. Okay, so here the branch point is moved here, ahead means before means it is moving to the before the block. So that means I am getting, so I am getting this branch point will be moved to here. So this is A, then G1, this same block, and here I am taking the tappings. So what is the tappings? Well, I have to get A into G1. So if you are moving forward, I will get only A. So I have to multiply it with again G1. So it is multiplied with G1 to get again same AG1. This is also AG1. Okay, so if before the block, if you are moving before the block, you have to multiply the gain. If you are moving the branch point after the block, you have to divide by the gain of the blocks. Okay, and the next rule is the moving the summing point. Okay, the moving the summing point is, so if you are having the summing point, then you can moving after the block. Okay, so what you have to do? So the next one is moving the summing point. Okay, we are moving the summing point, okay, ahead of the block. So what does mean that? So we are having some summing point where it is can add a two signal, that is A and B. Okay, so it is minus, it is plus, means you will get A minus B, and it will be given to some gain G. So you will get A minus B into the output is A minus B into G. Okay, so now I am moving the summing point ahead of the block. So what we will get is, if I am adding after the block, okay, so after the block means what is the final outcome? A into G minus B into G, that is the final outcome. So first we are to, before adding, I have to multiply A with G, B with G. So I am getting the thing as A is given to G and B will also be given to the G, and both the things will get added up. Both the things will get added up. Okay, so this is BG and this is AG, and based on the signal, the same signal we are following, this is a plus and this is minus, so we can get the resultant is A into G into A minus B. Okay, so this is ahead of the block. In the same way, the summing point can be moved before the block also. If it is before the block, just we have to divide it. Okay, so first before the block means so the same summing point. Okay, the summing point before the block. Okay, how we are going to moving before the block is, first we are taking the signal A and it is given to the G, and after that it has been added up. Okay, so the summing point plus minus and it is added up with the B. So if you take that, what will you get? A into G, AG, and B you will get AG minus B. Oh, this is our output of that block. Okay, AG minus B. So now we are moving into the summing point before the block. So before the block means what you have to do? So the resultant will be same. If we are moving here, so I am having the A. Okay, A G minus B should be the resultant outcome. So if it is A, then before the block, that means if you are having some summing point here, and after the summing point I am having G block here. Okay, that is the basic things. Okay, so I am moved the summing point before the block, so I am having summing point here and G here, so I need to get a AG. So AG means, so here it will be summed up plus and minus. So if you take this B, what will you get? A minus B into G, that is not a thing, AG minus B. So I have to multiply here with 1 by the gain of the block. So I will get, it is B by G, A plus B by G, and you are multiplying it. So we are getting A minus B by G, and if you multiply it with the G, you will get AG minus B. Okay, so this is the next rule, the before moving after and before the summing, that is a block. Okay, and interchanging the summing point. So the interchanging the summing point is, it is nothing but it is similar, because interchanging the summing point, So for example, you are having the two signal, it is A, it is B, and again it will be added with another signal, it is a C. Okay, if you are interchanging the summing point means this signal will be coming here and this is going that side. Okay, that means first you can take A and it will be added with, okay, so first the C will be added, and after that, so if you take that, it will be like this, the first summing point is coming here, so that is a C, so the C is added up minus, okay, so that result is given to the second summing point. The second summing point is with the two signals, which is A and B. So I am adding both the signals, it is a plus, one is A and another one is B, so I will get A plus B minus C, and here also I am getting A plus B minus C. Okay, so the interchanging the summing point is, the summing point 1 and summing point 2 will be, this is a summing point 2, this is a summing point 1. So we are interchanging the summing point 1 and 2. So the nothing will be happen while you interchanging it, but based on that we have to interchange the signals, that is very important. Okay, and splitting the summing points. So like interchanging, we can also split the summing point. Okay, the 8th point is splitting. So splitting the summing points. So splitting the summing point is the same summing points, plus or minus. So the same example, if you take it, it is A and this is B and this is C, the same things. We can add it in a one single block itself. So we can rewrite it like this. Okay, the same summing point can be splitted. Okay, so first it will be splitted with plus that is a B, A, and it will be given to the second summing point with the C. Okay, so the same output, the output is A plus B minus C. Here also output is A plus B minus C. Okay, so the very important thing is, so the summing point can be interchanged, or summing point can be splitted, or they can be combined. Even you can combine. The combining the summing point is, if there is a two summing point, in between them there is a no blocks, then we can add the two summing points with it, can give you a single summing point. In the same way, if you need it, we can split the summing point also. So the everything is possible in this block diagram reduction. And the next important thing is positive feedback and negative feedback, which is very important in the reduction of the block diagram. Okay, so that the positive feedback and negative feedback, so we have to derive the gain. So the derivation of the gain is not such a much important, but the formula is needed. So based on that, we can, while you are reducing the blocks, we have to use or apply that formula, then we can get the final reduced block diagram transfer function. So there is only two types of feedback. So it can be either positive or it can be a negative. Okay, so only some conditions the positive feedbacks are used, and some conditions the negative feedbacks are used. So when a positive is used and when negative is used means the positive feedbacks are used in a oscillators only, but in our control system the important thing is we have to use only the negative feedback, because we have to stabilize the system. Okay, so to stabilize any system we need only the negative feedback. Okay, but we can see that both the positive and negative feedback is present in the block. How we have to reduce it? Okay, the positive feedback is, so first elimination of the negative feedback and elimination of the positive feedback. So we are having a block. Okay, so this is R. Okay, R is a reference signal something, so and it will be given to the G, and it is coming out, the tapping is taken, and it will be feedback, the feedback is H, and it will be feedback, that's a plus and minus. Okay, if it is minus, that is a negative feedback. Okay, so what is the number? It is a 10. Okay, the 10th point is it is a negative feedback. So in the negative feedback is present, what is the final reduced a block diagram is? So this is the output is a C. Okay, so the final reduced diagram is G divided by 1 plus GH, and this is output and this is the input R and this is C. Okay, so G divided by 1 plus G into H, that is a forward path gain divided by 1 plus forward into feedback gain. Okay, and the negative feedback, this is a negative. If it is a positive feedback, if there is a positive feedback present, we have to reduce it into a single block. Okay, so the same take the same diagram with the plus, here also plus because it is a positive feedback. The first one is a gain, forward path gain, and this is a negative feedback H, and it is will be feeded back here and the reference signal R. Okay, so this is a simple feed forward block diagram or feed forward system with a positive feedback. Okay, in the positive feedback is represented and it will be reduced into the single block diagram or single transfer function as the forward path by G divided by 1 minus GH. Okay, if it is negative, you will get negative into negative positive, but in a positive feedback again we are having the negative sign. So you see that if it is a positive feedback, you will get a negative sign in a denominator. If it is a positive feedback, you will get a negative sign, negative feedback, positive sign. Okay, the interchange of sign is present in the denominator, just you note it out and don't forget it. So the reference signal R and your output C. Okay, so these are all the basic rules which will be used for eliminating or to reducing the blocks. Okay, so we can represent any equation into the block, and those blocks can be reduced into the single transfer function in order to derive the system transfer function. Okay, the system is represented with the help of the huge block diagram, but we need a single transfer function which will mimic or which will that is behave like a original system. So in such a conditions we are going to derive the block diagram reduction, which will give you the single transfer function and which can also be used to deploy the controllers onto those system. Okay, so first we will take the example to reduce the block. Okay, so I think this will be clear for a block diagram reduction. So before going into the problem, so I can summarize the points what we have discussed. First, what is mean by a block? A block is nothing but a element which is represented by the physical equation can be represented in a single block which is having one input and one output. Okay, so the block will process the input and it will give some output. So the transfer function is represented in a block. Okay, so every element, it may be a controller or it may be a actuator or it may be a sensors or it may be a process, everything are represented in a separate blocks. Okay, so even inside the process there will be n number of elements, those elements also having the n number of transfer functions. So those things are represented separately, and after separating and we are representing in the huge block diagram, we are going to reduce it into the single transfer function in order to control it. Okay, for that we are need rules for reducing those block diagram. So in the rules for reducing the block diagram, we have seen that there are 10 to 11 number of points. So the first one is the combining the blocks in series, we have to multiply it. When the blocks are in parallel, we have to just add the gains, and the moving the branch point ahead of the block or before the block. If you are ahead of the block, branch point is ahead of the block, just we have to multiply with the inverse of the gain, and if you are moving before the block, you have to multiply with the block gain. And the same way, like a branch point, we are also moving summing point ahead of the block and before the block, and we are splitting the summing point, adding up the summing points. Okay, then elimination of the negative feedback and elimination of the positive feedback. So those things are very, very important while you are reducing the block diagram. Okay, I think everyone is very clear about the block diagram and what is the rules for block diagram. So now let's move into discuss about a problem. Okay, so the problem is first we are taking a simple block diagram which will be used for reducing it to a single transfer function. So we are taking what is we are seeing that reduce the block diagram. Okay, so reduce the block diagram for the following figure. Okay, reduce the block diagram given in the figure. That is your question. Okay, so the first we are taking the reference signal R and it will be multiplied, that is a summing point. So you are having the forward path gain is G1 and G2 and G3. Okay, so it is G1 and G1 and it will be tapped out from here and it will be given to the G3. Okay, so this questions given for a simplification. Okay, and G1, after that you are having G2 block. Okay, then it will be added up in the summer. Okay, plus plus, then you are having the negative feedback. So the negative feedback is taken here and it will be added up here with a negative sign. This is a positive sign. Okay, this is a positive sign, this is a negative sign. So this is our output. Your output is C. Okay, so we are going to apply the block diagram reduction technique to simplify this problem. Okay, so we can start it. So what is the first one? What is the first thing? We can move it, either we can move this point here or this point here. Okay, so if you move this point here, that is nothing, that is a loop will present, that is a meaningless one. So we can move this point ahead of the block. Okay, so this point can be moved here. Okay, so if you move this point here, that is a nothing, meaningless loop. Okay, that is, so you should be moving in a meaningful way. So we have to moving this point here. Okay, so if you are moving this point that side, what we will get ahead of the block means you will get, if the tapping, if something is coming, something A, then after that G, then you are moving to this side while you are tapping it from the same A have to come out, but here G1 is multiplied while you are taking the thing. So the solution is, so first step 1. Okay, so move the branch point. Okay, so first one is move the branch point. Okay, here you take it, plus minus, the other things are remaining same. Okay, so I am moving this branch point. Okay, this branch point 1 and 2, I am moving the branch point 1 to the 2. Okay, so this is G1, the same thing is present, and I am moving this into this. Okay, 1, 2 both are present here, and this is the same feedback. Okay, sorry, it is the H1 is present in the feedback. Okay, H. Okay, this is a H, feedback gain is H. Okay, the feedback gain is H, and now you see that the same thing, this is forwarded here. So if you are taking it out from here, the tapping, it is given to the G3. So here only A is taken out. If you are taking here, it is A into G1. So what I am to going is, so I am tapping it from, then multiplied with 1 by G1. Okay, and it is again given to the G3. Okay, then it will be added up here. The same, this, the remaining thing will be, you have to move the same thing. Okay, the same summing point where positive and C. Only we are moving this summing point into this point. Okay, so we have to multiply it with 1 by G1. So we have multiplied with 1 by G1, then we have to reduce this blocks. Okay, so this is a simple negative feedback. If you see that, this is a negative feedback block, we can reduce it, and this is a series feedback. If you take this one, both the blocks are in a cascade, so we can reduce it in the step 2. So in a step 2, we can reduce the cascade block as well as the feedback block. What is the feedback block output? It is negative feedback, it is forward path gain divided by 1 plus forward path into feedback gain. So I will get, this is R and so it will be simplified into the single block. Okay, this will be simplified into single block. Okay, this thing simplified into the single block. Okay, so this is R, what is G1 divided by 1 plus G1H. Okay, it's clear. Negative feedback is replaced here. Then the same thing, the same point here, G3 by G1. Okay, G3 by G1, and this is G2. The both are in parallel. Okay, because it is added in a summer. This is C. Okay, now this will be reduced already, and here also we reduce. and here the only thing we are going to reduce is this one. Okay, so this is your the point where we can reduce it. Okay, this is both are in a parallel, this is parallel blocks. Okay, so just we are adding the output and we have to multiply it with this, we will get a final transfer function. So what is the output we will get? So what is the output you will get? If you had this one, then step 3 you reduce it. Step 3 R is given to G1 plus 1 plus G1H, and that will be given to this one, this is G2 plus G3 by G1. Okay, both the blocks are in parallel, so we are adding it and we are getting the output. Okay, C. Now you see that the two blocks are in a series. While they are in series cascade, you have to multiply. In the same way we are going to multiply this both the transfer function. So in a step 4, what we are going to do is we are going to just multiply the transfer functions. Okay, so now it is both are in a cascade. Okay, if you see that it is cascade. Okay, while they are in a cascade, this is also cascade. So while they are in cascade, just you have to multiply it with. Okay, so your output is R, and the single transfer function, what is single transfer function is G1 divided by 1 plus G1H. Okay, G1H into G2 plus G3 by G1. A simple block diagram with a C. Okay, so now we can represent it in an equation. C of S by R of S equal to G1 divided by 1 plus G1H into G2 plus G3 by G1. So if you multiply it with, you can get it the finalized output, or you can simplify this one, or without simplifying also we can forward it. Okay, so if you simplify this one as just you multiply here, what you will get, it is G1 divided by 1 plus G1H. If you take LCM, you will get G1 G2 plus G3 divided by G1. So G1 will get cancelled. Okay, the final thing is you will get G1 G2 plus G3 divided by 1 plus G1H. So this is C of S by R of S, that is a reduced transfer function for this system present in the diagram. Is it clear? So first you have to see that what things we have to move. So we should move in a meaningful way. So we cannot move this to here, because the loop will go here, means it will be a meaningless one. So we are moving here, this point is moved out of here. So while you are moving the summing, that is a point, we have to just divide by this block transfer function. Okay, so it will be reduced like this. Then this is a simple, so if you moved it here, means you are having this is 1, this is a negative feedback, and this is a cascade connection. We are reducing both the things in a single step. So nothing, you have to multiply it with, you will get this one, and for a formula you have to apply it for the negative feedback. So you will get G1 divided by 1 plus G1 H1, that is negative feedback, means you will get a positive here. Okay, then after that these two things are in parallel, so this is in a parallel connection. So now you are reducing this in a step 3. So just we are adding it. Parallel means we are adding the transfer functions, okay, blocks. So both the things are added up here, and you will get this one, then these two connections. So now it will be more or less simplified. The last step is just the two blocks in cascade connection. So we are going to multiply the transfer function of the two blocks. Okay, so we are again writing it in the transfer function C of S output by input Laplace of output by Laplace of input, we will get a transfer function. So G1 plus G1 is to G2 plus G3 by G1. So in this just we are simplifying and we are getting the final transfer function. Okay, I think you may be clear with the idea how we are going to solving the block diagram reduction for a particular system. Okay, so we can also having the other examples for reducing the block diagrams. So I think you may be clear with this. Okay. So if you have any doubts or any clarification, then you can text it. We can clarify your doubts. So next we can go for the another problem. Okay. Okay, so we can discuss the block diagram reduction problem. Okay. Already we discussed a simple problem. Now we are going to discuss about a second problem which is based on the block diagram reduction. So instead of the single loop, we can have some other n number of summing points or some more blocks in the diagram. So the same title, reduce the block, okay, and get the output C of S, reduce the block and find a transfer function C of S by R of S. That is the question. Okay, you may ask it in the any way. So first we are taking the reference signal given to some summer. Okay, and it is given to the block G1. Okay, block G1 it is given. Then you are also having the another summer. Okay, the summer which is having the positive sign here, and the another one is the negative sign with the feedback is here. Okay, then you are having the another block is G2. Okay, so after the G2 we are having another summer. Okay, the another summer. After that G3. We are having the another summer and the block G3. Okay, and G4. And you are having C. Okay, the C of S. Then you are having some other feedbacks and all. Okay, H1, H2, H1. Okay, H1 is coming here. Again here also you are having some negative feedback. Okay, this will be a long feedback without any gain. But another one is here the H2 is coming out from here and it is reaching this point. Okay, so you note it down. You are having the 1 2 3 4 forward block and 2 feedback gains, and you are having the 3 summers. Here also it is a positive, okay, negative. So now we are going to reduce this block diagram. So the output is C of S by R of S. We have to derive it. Okay, that is a block diagram reduction. We need it to solve. Okay, in this. So first what we are going, we are going to is moving the branch point before the block. What is the branch point? We are going to move the branch point. Okay, which branch point we can move? Whether either this one, okay, we can move this branch point, this point to this point. Okay, because you are having the 2 branch points, either you can move this one or this one. So we can move the final branch point into this point. Okay, so if you are moving that side, what will happen is, while you are moving this side, the final is taken out from here. So you have to multiply it with the G4 here, and also here the G4 will be multiplied. And this, the another thing is you can also move this branch point to that side. Okay, so what will happen is, while you are moving from this point to this point, we have to, here it is H2 and you are taking before, no, so we can divide it by G4. Okay, if it is ahead means we have to divide it by G4. You can either do it in a 2 way. Okay, so just we are moving the branch point this side. Okay, before. Step 1 is moving the branch point. Either this is a 1 2 means moving the branch point 2 to the point 1. Moving the branch point 2 to the first point. So while you are moving this side, what will happen? This feedback is taken out from here. That means it is before the block. Okay, before the block means, so we are just if you taking A, it is A into G is taken out. But if you are before the attack means it is only A. So what you have to just multiply it with G. Okay, that is the concept. No, so just we are redrawing same the things, but R of S we are reducing only few things. Okay, step by step we will move it. Okay, G1 and the second summing point with the plus and minus. The remaining things are same, only what we are reducing, that only we are going to reduce it. The remaining things we will copy the same thing. Okay, plus and minus. Okay, here it is G3 and the feedback is, what is coming is, it is H2. Okay, it is won't change because we are, this point we are maintaining, and after that we are taking it as G4. So this point is moved out here. Okay, this point is moved out here. So here you are taking the another feedback. This point is moved here. Okay, so this one is, what is H1? So the H1 connection is given here. No, so you will get H1 into G4. Okay, H1 into G4 here, because it has to multiply it with, and here also it has to be multiplied with the G4, and this will be given to here. Okay, just moving the point, and just we have to reduce this block, because we can reduce the block. So if you move this side, you can reduce this one, but we are moved 2 to 1, so we are getting the feedback loop here. You see that feedback loop. So for that only we are moving. Okay, if you just simplifying this one, you will get a cascade of these two things. You will get G4 into H1, and also you are having, this is a negative feedback loop. Okay, this is a negative feedback loop. Okay, so what anything else is can be simplified in this step? Nothing. Okay, we are reducing the negative feedback. Okay, the step 2 is, so reduce negative feedback. Okay, so you redraw these things, plus minus, and this is G1, H2, and this only simplified. Okay, this is G2. Okay, this a negative feedback is simplified. So before that it will be reduced into simple one, that is H1 into G4. Okay, so what is the formula for a feedback reduction is? It is forward path gain G3 divided by 1 plus feedback path gain. Okay, 1 plus G3 G4 H1. This is a feedback. This is reduced like this. Then from this one you are taking the tapping for this one and also for a G4. Here it is being given to here. Okay, G4 is coming out here. Sorry, here also you are having the G4, and this is C. Okay, so now you see that these two things are in series, and this is again another feedback loop. Okay, so if two things are in series, just you can multiply it with. Okay, so no need to go for the another step. Okay, so here we can reduce it in a single step. Okay, so this is another negative feedback loop. Okay, so if another negative feedback, it is a negative feedback. Okay, so this is a forward path gain, this is a feedback path gain. Okay, now we can reduce it here. Reduce it. What you are getting is G3 first, G2 into G3 divided by the whole things and divided by 1 plus this whole things into H2. Okay, I can write it here. So what we will get is, we will get forward path, that is a reduced block diagram is G2 G3 divided by 1 plus G3 G4 H1, the whole divided by 1 plus this thing, the same things, G2 G3 divided by 1 plus, sorry, I can write it here. So I can write it here. So we'll get in the step 3, we'll get R of S. R of S is plus minus G1. Okay, and the same thing, these things are modified now. So the forward path gain, what you will get is G2 G3 divided by 1 plus G3 G4 H1. Okay, okay, the whole divided by 1 plus G2 G3 divided by 1 plus G3 G4 H1 into H2. Okay, is it clear now? This is a, then it will be given to the G4, then C of S. Okay, from this point before the G4 we are getting the feedback which is G4, and it will be given to here. Okay, now you see that. So this is the gain. So we can reduce here, then we can move to the next step. Okay, so if you take this one, you'll get, here you can take the LCM we can reduce it, no. So the numerator and you take the denominator, you can take the LCM. So if you take this block, you will get the numerator is G2 G3 divided by 1 plus G3 G4 H1 the whole divided by, if you take LCM here, you will get 1 plus G3 G4 H1. So it will be here multiplied here plus G2 G3 H2 the whole divided by 1 plus G3 G4 H1. So this denominator and this denominator will get cancelled. Is it clear now? So just you have to take the LCM, and if you take the LCM, then you will get G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2. Okay, so we are replacing this with help of this transfer function because we are reduced the transfer function into this one. Okay, so I am going for again another block diagram reduction, which is a negative feedback. This is also a negative feedback. So I am again reducing the whole system with the negative feedback transfer function. So before that, we are replacing the transfer function with the reduced transfer function what we derived here. Okay, then it will be easy, you know. So the step 4 is, so instead of step 4, we are representing the same thing, we are redrawing the things. R of S plus minus G1, then this transfer function is replaced by this one G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2. Okay, then the G4 is here, then C of S, then the feedback G4. So now again this is in a negative feedback format. Okay, so this negative feedback is reduced. Okay, so how will you reduce with the same formula, G of S divided by G of S. So here you will get R of S and it will given to the transfer function. Okay, it is both the things are in cascade, so you can multiply it. Okay, so you will get G1 G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2. So this transfer function numerator, okay, this is a numerator transfer function, the whole divided by 1 plus GH, that is, this is whole G into this one. Okay, so now you will get the whole G is the same thing, you will copy it out, G1 G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2 into this G4. Okay, G4, here you have to multiply it with the G4 block and you will get a C of S. Okay, how will you reduce it is, so these twos are in series, so we can reduce it in a single step. So what you are getting, the final block is multiplication of these two blocks. Before that we can reduce this transfer function. This can be reduced as, so I will redraw here. How will you reduce this? So it will be reduced as, so this reduce and we can multiply it. So you can take the LCM G2, sorry, G1 G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 H2 the whole divided by 1 plus things. So we can, if you take the LCM, this will be multiplied here. So I will get 1 plus G3 G4 H1 plus G2 G3 H2. Okay, is it clear now? So we are taking the reducing this block, then we are forwarding it. Okay, this you will get multiplied with 1 plus, so this is a multiplied with 1, okay, plus G2 G3 sorry G1 G2 G3, okay, and it is also multiplied with the G4, okay. So the whole divided by the same denominator, 1 plus G3 G4 H1 plus G2 G3 H2. So now the same way this denominator and this denominator will get cancelled out, okay. So we will get this one G1 G2 G3 the whole divided by the denominator transfer function 1 plus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4, okay. This one and this one will coming here, the another two, the denominators will get cancelled out, okay. So now we are going to substitute here, this will be substituted here and we can reduce the transfer function in the next step. So what is the final thing is, so that will be replaced by this transfer function, then you have to multiply it with, it is in a cascade, okay. So we can just multiply it with, that's all. So the final transfer function C of S by R of S equal to this one into G4. So G1 G2 G3 G4, okay. How you are getting G4 is, it is multiplied, okay, multiplied because in a cascade. The denominator transfer 1 plus G3 G4 H1 G2 G3 H2 G1 G2 G3 G4, okay. So now you can see that the C of S by R of S, what it is asked in the question, okay. This is our final transfer function, okay. So this transfer function is the reduced block diagram of the system given in the diagram, okay. So now it's very clear that to reduce the block diagram, first we have to move the summing point or moving the branch point, then you are finding out is there is any negative feedback or any cascaded connection or any parallel connection. So you see one by one and you reduce the things, then finally you will get the reduced transfer function like this, okay. So this will be useful for finding the control system, that is defining the whole transfer function of the system and also to design the controller for the system. It will be very useful. So that's why you are reducing the blocks of the system, okay. Thank you.